In this video we're going to look at applications of trigonometry, and we should be able to recognise the correct rule to use, whether it's the sine rule or the cosine rule, and we'll also have to link it back to some of our M4 knowledge. So example A, find the area of the segment AB. So the segment AB is this shaded part here, and to work that out we're going to do the area of the sector minus the area of the triangle. Area of the sector is theta over 360 times pi r squared, so the angle fraction times by the area. And the area of the triangle is going to be a half AB sine C. Now the 8 centimetres is the radius, so it would be good for us to put the 8 centimetres on the other side as well. So what we've got then, two sides and the included angle to be able to use the half AB sine C. So if we put all the information in, we've got 100 over 360 times pi times 8 squared minus a half times 8 times 8 times the sine of 100, which is 55.8505 minus 31.5138, which gives us an area of 24.34 to 2 decimal places. Part B, the angle of elevation at the top of a building measured at point A is 25 degrees. So the angle of elevation is the angle that it takes to look up to a point. So that's our angle in here. At D, which is 15 metres closer, the angle of elevation is 35 degrees. So that's the angle to look up. Calculate the height of the building. So to work out the height of the building, what we really need is another side in either the inside triangle with a 35 or in the bigger triangle. So we would need some common length. So what we could do is we could work out the length of the line from A up to the house, and then, or the building, and then we could use trigonometry to work out the height from the right angle triangle. So I'm going to draw this triangle first of all. So this is an obscure looking triangle. And we know the base is 15. We know the interior angle is 25. And we know the exterior is 35. So if the exterior is 30 or 35, that means the interior angle is 180 less than that. So that's 145. So the angle at the top is 10. So what we want to do is work out this length here as x, which is related to the blue line above, so that we can look at the large triangle with x and 25 to use trigonometry to work out what the height is. So we've got these three sides. I'm going to label the triangle now A, B and C, and I'm going to label the sides small c, small b and small a. What we've got are all the opposites involved, so therefore it's going to be the sine rule, and we'll be using it for sides. So it's going to be A over sine A equals B over sine B equals C over sine C. Putting in the information that we have, it's going to be 15 over sine 10 equals B over sine 25 equals X over sine 145. Here we don't really care about any of the information about B, so we can forget about it, and we can cross multiply then the other two fractions to get 15 sine 145 equals X sine 10. And then dividing by sine 10, we get that x is going to be 15 sine 145 over the sine of 10. and that works out to be 49.546. So now if we look at our red triangle, we know x is 49.546. We want to work out y, when we've got x. So we need to label the sides in terms of the opposite, adjacent and the hypotenuse. The x is the hypotenuse, the y is the opposite, and the base is the adjacent. We don't know anything about the adjacent and we're not trying to find it out, so we can get rid of that. So whenever we look at our trig ratios, we can ignore the ones that have an a in them, so we can get rid of TOA and K. So we've got so is the sine of theta equals O over H. So the sine of 25 equals y over 49.546. Multiplying through by 49.546, we get that is being multiplied by sine 25 to equal y. So y, which is the height of the building, is equal to 20.9 metres to 3 significant figures. Part C, a fishing boat leaves the harbour H and travels due east for 40 miles. At B, the boat turns left and sails 24 miles to lighthouse L. It returns to the harbour at a distance of 57 miles. Find the bearing. Now bearing, they're measured from a north line in a clockwise direction and must have 3 figures. So find the bearing of the lighthouse from the harbour to the nearest degree. So what we'll be looking at, or looking for, is this angle in here. So to work that out, if we could find the angle in here, so the one marked with a star, and the full angle is 90 degrees. So we were told initially that it travelled due east. So this is a right angle. So if we can work out the red star, we can take it away from 90 to get the bearing. So what we need to do is label the sides H, B and L by the looks of it. So L is the lighthouse, that's the angle at the top. So the side is the due east. B, opposite B is 57, so it's going to be a small b. And opposite the harbour H is 24, so it's small h. And what we're looking for is angle H. So we're going to use the cosine rule. We've got 3 sides. And we need the angle, so it's the cosine rule, and it's a cosine rule for H, so that means we're going to be doing the cos of H, and that means we're going to be taking away an H squared, and everything else is in terms of the other letters. So the format is it's B squared plus L squared and over 2 times B times L. So let's put in the information then. We get the cos of H equals 57 squared plus 40 squared minus 24 squared over 2 times 57 times 40. So the cos of H equals 0.93706, and then H is going to be cos to the minus 1 of 0.93706. And making sure our calculator is in radian or degrees, so there's a D or a DEG at the top, and doing the shift cos, we get 20.44 degrees. That means the angle on the other side is going to be 90 degrees less than that, so 90 minus 20.44 is 69.56 degrees. So therefore the bearing, which must have 3 figures, is 069.56 degrees to 2 decimal places. And we need the 0 because it has to have 3 figures. Question example D then, the diagram shows the position of 2 trees, D and E, on the bank of a river. The river banks are parallel. F is the position of a tree on the opposite side of the river. And we can see the angles from each point to the tree F. And we want to calculate the width of the river. So I'm going to mark on the width of the river, and I'm going to mark it from F, and it's going to be a perpendicular. So to work that out, we might be thinking, well, there's a right angle triangle. There's two right angle triangles, but there's a right angle triangle. All we need to do is work out the length of the base or the length of the hypotenuse in the right angle triangle. And if we know one of those two, we could use simple trig with the angle 74 to work out the width of the river. So we've got two sides or two angles and a side. We could use the sine rule then to work out either diagonal. So I'm going to redraw the triangle, labeling the sides. I'm going to put in 74 and 58. And staying with the green line, I'm going to call this X. Now we need to work out this third angle, but the three angles inside a triangle add to 180. So if we add 74 and 58 together and take that away from 180, we get that the top angle is 48. So we get D, E and F. The sine rule is, in terms of that, is going to be D over sine D equals E over sine E equals F over sine F. So what we need to do is label the sides. Now the 200 is going to be small f. The DF is denoted with small e, and FE is small d. So putting in what we have, we get x over sine 58 equals e over sine 74 equals 200 over sine 48. And the middle one we don't care about, we're not interested in e. So if we cross multiply, we get x sine 48 equals 200 sine 58. X then is going to be 200 sine 58 over sine 48. And that is 228.232 meters. So now we have this right angle triangle where the angle 74, the hypotenuse is 228.232, and we're trying to find the height. I'm going to call that y. So it's a right angle triangle. We don't need to worry about the sine rule or the cosine rule. We can use simple trig. We need to label the sides first of all. The 228 is the hypotenuse, y is the opposite, and the base is the adjacent, which we don't care about. So whenever we think about so, ca and toa, we need to get rid of the ones that have the adjacent. So we get rid of toa and ca, and we're left with so. So is the sine of theta equals the opposite over the hypotenuse. So sine 74 equals y over 228.232. Multiply up by that, we get 228.232 sine 74 equals y. So y then is equal to 219.4 meters to one decimal place.